So I'll put the examples up here. We've got the integral. Cool. And C.
Oh my god.
Honk.
Bless you. Okay, so let's do these first few first. So we're just applying the rules. Now it's like differentiation in that we need to express everything in the form x to the power of n. So if we look along here, everything's expressed as x to the power of n, and we're ready to differentiate. The rule is the integral of x to the n is x to the n plus 1 on n plus 1. Okay, so let's get into this one here. We've got the integral, and we're going to integrate by parts. Just like differentiation, we're going to differentiate all in one step. We're going to integrate all in one step. So right here, we're going to have, it's going to be x to the 3 plus 1, which is 4, on top of 4. Okay, if you want to differentiate this, right, we're going to have 4x to the 3 on top of 4, and the 4 and 4 will cancel, we'll have x to the 3. Very good. Here we've got 4 times, remember it's just a number, so that's just going to hang out the front. And the integral of x is going to be x to the 1 plus 1, so that's 2 and 2. The integral of k is kx, so we have to take 2x. And then we always put plus c. All right, plus c for some number that could be there that has disappeared when we've differentiated. That would be our answer. That would be our answer without simplifying, and it could be simplified.
So can each of these rules, is that just term by term?
Yep, absolutely. Yep, we're integrating term by term. Yep.
Roger.
Okay, up here we're going to need to express this as x to the power of n. So that's going to be x to the power of a third. Take away 4e to the x. Alright, so this here is going to be, I'm going to do this one slowly. It's x to the third plus 1 on top of a third plus 1. Then we have take away 4 times. Now the integral of e to the x is just e to the x. Alright, that says that in our book there. Integral of e to the x is e to the x. And then we have our plus c. Alright, so this is going to be x to the power of 4 on 3. On top of 4 on 3. Which is x to the 4 on 3, but when we're dividing by 4 on 3, it becomes 3 on 4. There we go. There's A and B. Okay, any questions so far? So what do you reckon, Austin? You've seen it for the first time, like just following the rules?
Yeah.
So like, I don't expect you to know what it means, but it's just like follow the rule.
Yeah,
That seems okay?
That's good.
Excellent. All right, let's jump up here. We have 3 on x. We're going to first express this as 3 times 1 on x. We get plus 2 times x to the minus 2, and then plus sine x. Okay, so that's what we're trying to find the integral of. dx, because we're always integrating with regards to x. Now the integral of 1 on x is ln x. Okay, so this is 3 ln x, that's in our table there. But we also know if you differentiate ln x, you get 1 on x. So that means if we integrate 1 on x, we're going to get ln x. Here that 2 is going to hang out, and we have x to the minus 2. We're just going to perform the rule there, so it's going to be x to the minus 2 plus 1 on top of minus 2 plus 1. And then the integral of sine x is negative cos x. Okay, so let's simplify there. We've got 3 ln x plus, it's going to be take 2x to the minus 1. And then take cos x. Alright.
What about C?
Plus C, thank you. If you ever see me forget, let me know. Don't forget to press that plus C button.
Wait, is that what it means?
Nice.
What does that mean? What's aspirin doing? Spirit.
Oh, tissues.
Oh, plus C.
Are they included in the box?
Yeah. Well, I'm disagreeing again.
It's got the plus C on the back.
What?
Oh, really?
Yeah.
What's a spiridum mean?
Oh.
She. You just swore on camera, Austin.
All right.
It's a she.
Question 2a. We have 4 cos x take 3. B is x root x on top of take 3 on top of x squared. I don't like this text here. And C is x take 2 squared. Okay, so it says in question 2, find the antiderivative. What that means is perform the integral of this with regards to x. Okay, that's what it's going to mean. So we'll use both kinds of language to get you familiar with the notation. So if we're looking here, what this is, like one way you can break this up, I've said we're integrating term by term. All right, so what we're doing is we're performing 4 times the integral of cos x with regards to dx, take the integral of 3 with regards to dx. Like, that's one way you can think about it. And then we're just going, well, the integral of cos x is sin x, the integral of 3 is going to be 3x, and then we have plus c. All right, so we're just following the rules. Here, before we can perform the integral, we need to express everything as x to the power of n. So at the top here, we've got x root x, which is x to the power of 3 on 2. All right, and then we can split the denominator. So that's going to be x to the 3 on 2 on x squared. Take 3 on x squared. Don't forget your dx's. Okay, and then we can use index laws to simplify this. And then we're ready to perform it. We've expressed everything as x to the power of n, just like we do in differentiation. So that's going to be x to the minus half plus 1 on top of minus half plus 1. Take 3 times x to the minus 2 plus 1 on top of minus 2 plus 1 plus c. I don't need that there, I'll perform the integral. So we've got x to the half on top of half. Take 3 plus 3, x to the minus 1. Plus c. Plus c. Alright, so that's 2 root x plus 3 on x plus c.
That is too hard.
What do you think of this?
I'm a bit lost.
Yeah.
Alright.
Yeah, like I'll ask you a question. Any questions?
No, it's just you're just going through it really quick, which is fine.
Yeah,
It just takes a bit more time.
So this process here, I mean, we've done that relentlessly in calculus, all right? So I mean, that's nothing outrageous. And then here, we've expressed it as x to the n, so we're just following that rule, x to the n plus 1 on top of n plus 1. Here it's x to the n, so that negative 3 is hanging up front, x to the n plus 1 on top of n plus 1, and then it's just simplified. Okay, before we can perform this, we need to perform that expansion. All right, we will learn a rule for ax plus b to the power of n later, but for now, let's perform the expansion and then integrate it. It's going to be x squared take 4x plus 4. Okay?
Just back to that last one real quick.
Yes.
Can you leave it as the second one, or do you have to simplify it down to the bottom?
There.
Yeah.
Again, it'll say either integrate without simplifying or show that. If it says without simplifying, like even there's fine. Yeah. Just looks messy, doesn't it? So yeah, it's exactly the same as differentiation in that regard. Okay, so here we've expressed everything as x to the n, we're ready to integrate. So first one here, it's going to be x to the 2 plus 1 on top of 2 plus 1. Take 4 times x to the 1 plus 1 on top of 1 plus 1 plus 4x plus 4x squared on 2. Alright. Okay, so here question 3. This is a great question because this is going to cover what you guys did in D yesterday if you completed. Now, can I write this out?
Can you? Is that okay if you leave that? Is it
Say
okay?
again?
What do you mean?
I probably have it here. I probably have.
Probably flip the
I'll
ball.
leave it. We'll leave it. Let's do it up over here. So we have
Yeah, do the flip.
find D on D. Nah, I've got to do product for all the stuff. No, I'm not
Flip the
doing-
board, sir. Yeah, flip the board.
Let's flip the board.
Noise.
Oh.
Damn. Year 11s. Get rid of it.
Whose handwriting's that? That's horrendous.
They stink.
What's that yours?
No, it doesn't.
Whoosh.
Definitely.
You missed the corner.
Okay. Find D on dx of x sine x. Okay, so that means differentiate what's in the brackets there. Here we have x sine x. We have to use the product rule to differentiate that. So we have u is x, u dash is 1, v is sine x, v dash is cos x. When we differentiate this, it's going to be 1 times sine x, u dash v, plus u v dash. Okay?
Wait, is that backwards?
U dash v
Is
plus u v dash.
Is that the same as we did in
No, this is
differentiation, or is it
differentiation.
backwards?
This is what it says, find the derivative.
Oh.
Differentiate it. Okay, so then let's make an integral statement about it. If this is the connection that we waited with this, if we differentiate this, we get this. Alright? That's going forward. So then if we're going backwards, the integral of sine x plus x cos x. Okay, if we're going to integrate this, we say, what? When we do that, we're saying, what did we derive to get this? Well, we know it was this, x sine x. Okay, so that's the link that we're making between.
Easy.
If we differentiate this, we get this. Therefore, if we integrate this, that's that statement there. If we integrate this, that's what we're going to get.
Is that all you have to say when you're doing that?
That's the statement there. Integral of this is that because derivative of this is that.
So that's it.
That's not the answer, no. Because it says it wants to know specifically the integral, what's the question? Find the integral of x cos x. Now, one of the properties of integrals is we integrate term by term. So that means this integral we can apply to each term respectively. Don't get your dx's. Okay, and now, if you look at the question, what's it asking us to solve? It says find this. It wants us to isolate that part by itself. This is an equation, all right? So we're just going to subtract this from both sides. Okay, subtract that from both sides. So that means I'm going to have the integral of x cos x is going to equal x sine x. Take away this part, I'm moving it over this side. Okay. Integral of x cos x is going to be x sine x. Take away, what's the integral of sine x? Negative cos x plus c. Okay, so we need to perform that step. And then what we have here is x sine x plus cos x plus c. Okay, so the link here then, what have we done? We've done some pretty cool stuff. We're saying if we differentiate this, this is what we're going to get. Therefore, if we integrate that, this is what we're going to get. We've split the integral and we've said we want to know what's the integral of this part. We can't integrate that. It's some sort of product. We don't have a rule for that. All right. But what we're doing is we're seeing a link between here and here. We've split the integral. We've isolated this part, shoved that over, And now we have the integral of x cos x. Okay? What does it mean? It means if you differentiate this, you can go ahead and perform it if you like. This is what you're going to get. Okay? If you differentiate this, you get this. If you integrate this, you're going to get that. Right? Working forwards and backwards. So, let's give it a go. If you're still struggling, I probably might like to do a bit of stuff with you guys individually. So, yep. But if you're feeling confident, let's get into it.
Questions?
Yes, of course.